Hello students, welcome to LearnGuru Classes. So today we are going to solve some sums related to laws of exponents. So let's begin the class. So the first is prove that a to the power of minus 1 divided by a to the power of minus 1 plus b to the power of minus 1 plus a to the power of minus 1 divided by a to the power of minus 1 minus b to the power of minus 1 equal to 2b square by b square minus a square. Okay, so let's start with LHS. LHS, what is given to you? Let's write this particular expression, a to the power of minus 1 divided by a to the power of minus 1 plus b to the power of minus 1 plus a to the power of minus 1, a to the power of minus 1 minus b to the power of minus 1. So, you know very well that if a to the power of minus n is there, we write it as equal to 1 by a to the power of n. Similarly, same way, in place of n, if we replace it with 1, so it will become 1 by a. So, since here a to the power of minus 1 is given, b to the power of minus 1 is given, so you are to replace it with this particular expression. Okay, so a to the power of minus 1, straight away I will write it as 1 by a. Here also I will write it as 1 by a plus b to the power of minus 1. So, how will you write b to the power of minus 1? You can replace it with 1 by b. So, this is plus of 1 by b plus a to the power of minus 1. I will write it as 1 by a, and this is 1 by a minus 1 by b. Okay, now what we will do? We will take 1 by a, we will keep 1 by a as it is. Here in the denominator, we will take the LCM. So, 1 by a plus 1 by b, so LCM will be ab. So, this will be a plus b. Similarly, here it will be 1 by a, this will be ab, and this will be b minus a. Okay, so this will be 1 by a, so it will be what? Just we will write it as ab divided by a plus b, isn't it? And plus of 1 by a, and this, since it is divide, so ab will be in the numerator and b minus a will be in the denominator. So here I can cancel a cancel, here also a cancel. So you are getting b divided by, here a plus b, we can write it as a or b plus a, same thing by commutative law, plus b, and this will be written as b minus a. Now here also you are to take the LCM. So how will you take the LCM? What will be the LCM? B plus a into b minus a. Okay, so here b, let us take as common, or b into, this will be b minus a, b minus a plus b into b plus a. Okay, now take the do the simplifications, do the multiply, b square minus ab plus b square plus ab, and a b plus a into b minus a. How we can write? What is the formula? It will be, it can be replaced as b plus a into b minus a, can be written as b square minus a square. Okay, so this one we will write it as b square minus a square. So ab minus ab will get cancelled. So you are getting 2b square divided by b square minus a square. So are you getting the result? Yes. So equal to RHS. So this is hence proved. There is no place of writing. So I am writing here proved. Okay. So this is the first sum. Okay. So let's look into the next sum. The next sum is prove that 1 divided by 1 plus x to the power of a minus b plus 1 divided by 1 plus x to the power of b minus a equal to 1. So we will start with LHS and see whether it matches with the RHS or not. Okay. So 1 divided by 1 plus x to the power of a minus b plus 1 divided by 1 plus x to the power of b minus a. Now you have to decide which formula will work here. Okay, from the law of indices, which formula will work here. Now if you see here, it is given as x to the power of a minus b, x to the power of b minus c. Means what? The powers are being subtracted over here. Okay, a base is there, x is working as the base and the powers are, that is b and a, are being subtracted here. Okay, now from that you can make out that it has the same base. So which formula will work? This formula will work for you. X to the power of b by x to the power of a. What happens here? Bases are same and both these two terms are being divided. So what will be the expression? X to the power of b minus a. So it is given here. X to the power of a minus b, or if I say x to the power of a by x to the power of b, so x to the power of a minus b. So easily I can replace x to the power of a minus b by x to the power of a plus by x to the power of b. Similarly, x to the power of b minus a I can replace with this value. Okay, so let's see. So this will 1 divided by 1 plus, so this is becoming x to the power of a by x to the power of b plus 1 divided by 1 plus x to the power of b by x to the power of a. So this is becoming as 1 divided by x to the power of b, x to the power of b plus x to the power of a plus 1 divided by 1 LCM is x to the power of a. So this is x to the power of a plus x to the power of b. So x to the power of b will be taken as the numerator here, x to the power of b, xa plus xb plus here x to the power of a. Sorry, this will be x to the power of a, x to the power of b. This is x to the power of b, x to the power of a plus x to the power of b. So take this as LCM. So this gets cancelled. So ultimately it is equal to 1, that is equal to RHS. So hence proved. Okay. So hence proved. So this type of sums are very easy once you know how to utilize the formula. It is of no point of memorizing the formula. You should know where and how to use those formula in the problems. Okay, then the things will not be tough for you and you can achieve this with the help of practice. Practice as much as you can. Try to solve your textbook, R.S. Agarwal, R.T. Sharma, try to solve sums from these books, then automatically you will gain your confidence. Okay, so let's move on to the third sum. The third sum is, see, you have to simplify this particular expression. Now from this you can see very well that x to the power of L by x to the power of m to the power of 1 by ln. Okay, so means power within power. So let's see this, the terms within the bracket. So from this it is clearly you can see that both of them has the same base, that is x, and the powers are means x to the power of L divided by x to the power of m. So here what you have to do, simply you have to subtract the powers. Okay, so let's proceed. So this will be x to the power of L minus m. Within bracket we can write it as 1 by lm. So this is power to the power to power, isn't it? So here also it is the same, x to the power of m minus n by to the power of mn. Okay, and next is x to the power of n minus l to the power of 1 by n. Okay, now again you have another formula from law of indices, that is, if x to the power of a is there, again if it is placed under another power, so what we do, we multiply both the two powers. Okay, so this formula is known to you. Now here this is one power, L minus M is one power, and another power is 1 by Lm. So simply you are to multiply those two powers. So simply we can write it as x to the power of L minus M into 1 by Lm. So straight away we can write Lm. Here also same thing, x to the power of M minus N divided by Mn. And this is x to the power of n minus L divided by n. Now here also you can see that now what happens, you are getting the product terms, isn't it? Now from the product try to examine the base. Yes, bases are same but powers are different. So what formula will work? So is it of the form of xa into xb, x to the power of a into x to the power of b into x to the power of c? So under this case, what do? You just add the powers. Yes. So similarly here also we are going to add the powers. Okay. So here x to the power of L minus M divided by Lm plus M minus N divided by Mn plus N minus L divided by NL. You are getting this particular expression. Okay. Now you take the LCM as M, L, M, N. Okay. Now from that n into L minus M plus L into M minus N plus M into N minus L. Now try to multiply this to all the terms. So this is L, M, N, N, L minus M, N plus L, M minus N, L plus M, N minus M, L. So M, L or LM, sorry, LM also you can write M, N. Both of them are same. So this positive and negative will get cancelled. Here also positive and negative will get cancelled. Here also positive and negative will get cancelled. So you are getting x to the power of 0 by LMN. So anything by 0 is what? 0. Isn't it? So here x to the power of 0 by LMN is what? 0 by LMN is 0, isn't it? So we can straightway write x to the power of 0. So anything to the power of 0 is a to the power of 0, we can write it as 1. So x to the power of 0 also we can write it as 1. So thus we have simplified this particular complex expression. Okay, so let's move on to the fourth sum. The fourth sum is you have to simplify this expression. Okay, so x to the power of p by x to the power of q. So both of them has the same base but powers are different and they are being divided. Okay, so what you have to do, you know very well, x to the power of p by x to the power of q, we can simply write it as x to the power of p minus q. Okay, so here you can write it as x to the power of p minus q, close the bracket. Okay, this is another power, that is p plus q. Okay, here also same base, both of them are being divided. So you have to subtract the powers. So this is q plus r. Okay, and here it is x to the power of r minus p to the power of r plus p. Okay, so again you know very well that power within power means you are to multiply the two powers. Okay, so p minus q into p plus q. So what is this? It is of the form of a plus b into a minus b. So a plus b into a minus b is a square minus b square. So no need of extending another, writing one step, straight way I will write it as p square minus q square. Now here also it is of the form of a minus b into a plus b. So we will write it as q square minus r square. Here also x to the power of r square minus p square. Now all the here if you see, all of them has the same base but powers are different, and all of them are being multiplied with the same base. So what formula will you use? If it is of the form x to the power of a, x to the power of b into x to the power of c, we write it as x to the power of a plus b plus c. So here also we are going to apply the same formula. So p square minus q square, again I will add these powers, q square minus r square plus r square minus p square. So p square gets cancelled, this gets cancelled, this gets cancelled. So x to the power of 0, so that is 1 is the final answer. Okay, so let's move on to the fifth sum. The fifth sum is you have to prove that this particular expression is equal to 1. Okay, so let's start with LHS. So LHS equal to root over x to the power of minus 1 y into root over of y to the power of minus 1 z into root over of z to the power of minus 1 into x. Okay, now how to proceed this? How to proceed with this? Now if you see, within these terms are under the root, so let's remove the root. So how will you remove the root? You know very well that if suppose root over a is there, so you can remove the root and just replace it with a to the power of half. Okay, so same thing, you can remove the root from here by replacing it with to the power of half. Okay, so this we can write it as x to the power of minus 1y half. Yes, here also we can write it as y to the power of minus 1 into z to the power of half, and this we can write it as z to the power of minus 1 into x to the power of half. Okay, so this is power within power, x to the power of minus 1. Minus 1 is a power, this is a power. Okay, so what happens here, these have the bases are different but powers are same. Like a to the power of n into b to the power of n. So both of them have the bases are different. So what we do, we just multiply the base to the power of n, isn't it? So here also it is the same. X and y are two different bases, but power you are having as half. Again you have within x to the power of minus 1 is there, of course y to the power of 1. Y means y to the power of 1, isn't it? So what I will do, x to the power of minus 1 half. Okay, let me show you with another extra step, though you don't need this step, but still I will show you. So y to the power of, this will be minus 1 half, z to the power of half, this will be z to the power of minus half, and x to the power of, or minus 1 to the power of half, x to the power of half. Okay, so minus 1 into half is minus 1 by 2. So x to the power of minus 1 by 2, y to the power of half, y to the power of minus 1 by 2, z to the power of 1 by 2, z to the power of minus 1 by 2, x to the power of half. Okay, so x to the power of minus 1 by 2 and x to the power of 1 by 2. So both of them has the same base but powers are different. Okay, so let's separate the terms that has the same base. Here also y to the power of half into y to the power of minus half, and this is z to the power of half into z to the power of minus half. So same base, x to the power of minus half and x to the power of half, same base. So what I will do, y so minus half plus, it will get cancelled. So x to the power of 0, y to the power of minus half plus half, it will get cancelled, y to the power of 0, and this is z to the power of 0. So x to the power of 0 is 1, y to the power of 0 is also 1, z to the power of 0 is also 1. So 1 into 1 into 1 is 1. So equal to RHS proved. Okay, so this is how you solve this type of sums. Okay, once try to remember the formula. You have to learn how to implement this formula in the problems. By just looking at the problem, you have to judge which formula you have to use. Okay, so this is the key. Okay, and this can be achieved, again I am telling you, this can be achieved easily if you solve, if you try to practice as many as sums possible. Okay, so I am ending the class here. Next class also we will be solving sums related to this chapter. Okay, so I am ending the class here. So if you find this video helpful, please subscribe to LearnGuru Classes, like, comment and share it with your friends and relatives. So thank you so much. Bye-bye.